So I'm going to talk today about Credo. Credo is a climate change adaptation digital twin. Hopefully that's familiar to people on the call. It brings together data from across energy, water and telecoms networks with flood data, and fundamentally helps the system to understand kind of how to improve resilience and adapt. Essentially, we're in a world where resilience planning tends to be undertaken at organisational level rather than across systems. But we all know that pressures on infrastructure are increasing dramatically over time. Credo helps because it looks at network vulnerabilities from a system perspective. So it brings together information from across different asset operators to understand how those assets interact with each other in the event of a failure, for example, from a flooding event. And it provides inputs for decision makers to support them with making the right investment planning decisions with regards to has brought some material improvements relative to the early phase. So talk about three. Firstly, there is Credo now includes real data on assets. Previously was using synthetic data to illustrate the use case. It now uses real data on those assets and their interconnections, as well as real data on existing resilience measures in place by asset operators. It covers a broader geographical area than it did previously, which was a very small area of East Anglia. And also it's able to cope with understanding and analysing a range of different types of flooding event. It also, and this is where myself and Fulvio come in as economists, it importantly now builds in cost benefit analysis. And essentially there, it helps to understand kind of the impact of interconnectedness in terms of the costs that any failure kind of incurs on the system, which then in turn helps asset operators plan for the most efficient system-wide changes to make to improve their resilience. Essentially then, the cost-benefit analysis in Credo has allowed us to quantify impact that outages caused by floods bring. So it has two sort of key decision support tools involved in Credo now, which are integrated within the model. Firstly, it enables us to look at which assets are most critical in the system. So in the event of a failure, which assets incur the most cost on the system, and therefore which interventions are most beneficial to reducing those costs. And when we talk about costs there, we're really talking about costs to asset operators, costs to consumers of outages, as well as sort of wider environmental impacts of kind of flooding events. We look at it under two key scenarios as well. So firstly, we compare the sort of siloed view of resilience, where each asset operator makes decisions in isolation for each other, with a system view of resilience, whereby Credo is kind of taking a system view, and compare those to understand the situations where actually a system view leads to a better overall economic outcome for the asset operators and wider society.
Well, maybe I can take over from here. Thanks, Sarah. And as Sarah said, we managed to implement develop a methodology that allows to estimate this cost, and we consider three buckets of cost. So cost to asset operators, cost to customers, and negative externalities. So our methodology consider for asset operators the cost to contain and prevent failures due to climate change and flood for Credo phase 2, and also the cost of repairing the assets that have been damaged by flood. Then we consider the cost to customers, which are the costs connected to their inability to use the essential services provided by these asset operators. So, for example, not having access to running water or electricity. And then we consider negative externalities. In particular, for our methodology, we consider the cost of pollution incidents caused by outages. As Sarah mentioned, these enable to unlock two use cases for decision support. So the assessment of criticality and comparison of resilience interventions. So in terms of assessment of criticality of each of the assets, we did that we developed a methodology that allows to do that under two scenarios, so that siloed view and the system view. And something that is really important to note is that that assessment of criticality, it does not have to be the same under these two scenarios. And this is illustrated in this graphic, where we have a simplified electricity system with two assets, one connected powering the other. And the assessment of criticality of that second asset at the top would be a low level of criticality, because if that asset fails, it doesn't cause any other cascading effect because it's not connected to any other assets. However, that assessment does change once you consider the reality that electricity assets do provide power to assets of other network operators, in this case, telco and water operators. And if you assess the criticality of that assets under this system level view, you can see that it's actually much more critical for the system, because when that asset fails, it does cause widespread outages throughout the system. So it is one of the key output that this CBA methodology allowed to unlock within Credo, so assessment of criticality. The second output that Sarah mentioned is comparing different resilience investment strategies. So Credo now allows to understand how the system can be made resilient and evaluate potential different ways of making the system resilient and what it means in terms of avoided costs, so the benefit that that potential investment strategy can have. And this is quite powerful because it can help decision makers decide upon competing options. And to make this assessment, we implemented that cost-benefit analysis methodology, those three buckets of cost I mentioned earlier, to understand the cost related to preventative and containment measures, and then ultimately the output that potential outages driven due to a flood have on customers and asset operators, and negative externalities. So that's the second key output that is unlocked by the cost-benefit analysis methodology we have developed. So to illustrate how this can work in practice within Credo, we actually implemented the methodology within Credo, and this is with a specific flood scenario in an area of England, and then we evaluate potential different investment strategies given a level of investment available, and this is shown in the chart at the top left of this slide. Where you can see on the x-axis the level of investment available, on the y-axis potential benefits due to increasing the resilience of the system under these two different strategies, the siloed view system assessment of resilience, which is the blue dots, and the yellow dots is the Credo view. And you can see that the yellow line is generally higher than the blue line, meaning that making an investment that takes into account a system assessment of criticality and resilience would lead to higher benefit given a certain level of investment. So just to recap, we developed a cost-benefit analysis methodology that we think allowed Credo to unlock some of the decision support use case, in particular assessment of criticality and comparison of resilience interventions. And today we are, there are reports that summarize all of what we have done and explained today is going to be published. There is more detail in our report, obviously, so I invite you to download it if you're interested, and you can find out more about our methodology and the case study. Now going to hand back to Sarah for some concluding remarks. Sarah, over to you.
Benefits of Credo are very broad and go beyond the specific use cases that we have talked about today. So they also include being able to improve responses to flooding events, being able to develop more efficient and effective ways to share information between organisations and being able to look at spillover effects. With that, I will conclude and hand back.
So our first question is to the Credo team, is with Credo, are you considering the cascade impact where the downstream impact gets more significant as, for example, power outages cause IT impacts, which in turn affect important business services?
Yes, so shall I answer that, and then Fulvio, you can add. So yes, we do consider sort of the downstream impacts on kind of consumers, and we do that by using something called willingness to pay. So how much will it, which is sort of captured in regulators' sort of regulatory agreements with the asset operators in question. So willingness to pay sort of indicates how much people would pay to avoid outages. So how much they would pay to avoid the sort of events that we're talking about being caused by flooding events. I think it's fair to say, though, that that willingness to pay reflects probably more heavily impacts on individual consumers rather than sort of specific businesses. But it should capture an element of both, and certainly there will be some business impacts caught within that. What we don't do is sort of look at critical business services, for example, kind of hospitals or kind of really critical pieces of other infrastructure at this point. I think that is something that is being considered as an additional kind of work stream.
So question back to Sarah and Fulvio. The Frontier Economics report is nearly 40 pages. Is there a plan to produce a summary document targeted at key audiences, for example, policymakers, to help them decide to investigate further?
Yes, our report is quite long, I admit it, but we do have an executive summary, which is just a couple of pages, so hopefully that will be helpful. There is also a section at the very end of the report where we indicate further ways that Credo can add value to decision makers, so hopefully that would help inform what Credo can do and will be interested to different audiences.
Very good. And last question, please, for the Credo team, is can the Credo methodology be replicated in other contexts?
I'll have a go at answering that. I think obviously the focus of the Credo methodology as it currently stands has been on looking at flooding events. There is a desire to extend that to other sorts of environmental events. So things like extreme heat would be one example where the interconnections of asset operators could be important in planning the appropriate response to those sorts of events. But there are also kind of considerations around how you expand what's been done to capture other sort of more critical services in the areas, like I mentioned earlier. So things like, you know, hospitals, important kind of businesses, those sorts of things are also on the, you know, potentially on the horizon. I think there's a very kind of important prioritization exercise that the Credo team have to go through each time to try and decide which is the next useful kind of use case to, you know, essentially use the tool for. But yes, there are things on the horizon, hopefully.
Brilliant, thank you.